So we see now how to transform a couple of different equations to this new form, which is really helpful for us in certain ways. But there are a lot of different equations for parabolas that don't look just like these two. In particular, what if our equation doesn't have a leading coefficient of 1? Leading coefficient here refers to the coefficient in front of the x squared term, the term with the highest power. In both of these situations, that coefficient is 1, which we know makes factoring a lot simpler, and presumably also changes how we complete the square. In fact, recall the equation that we came up with as our final equation for calculating Grant's profit based on the price that he charges per glasses wiper set. Last lesson we had P equals negative 200C squared plus 18,400C minus 133,200. Here our leading coefficient is negative 200. That's certainly not equal to 1. If we want to find out exactly where the vertex of this equation is, we're going to need to get this in that new form using completing the square. Well, we'll get to solving this eventually, but for now I'd like us to start out with an equation similar to this in that its leading coefficient is not 1, and then we'll work through that to eventually be able to deal with the Grant situation. Here I've graphed the equations y equals x squared, that parent parabola we've seen so many times, and then a second parabola, y equals 3x squared, this green one right here. So judging from the relationship between these two graphs, how does multiplying the leading coefficient of a parabola change the shape of the parabola? Does it shift it vertically, shift it horizontally, make it wider, or make it more narrow?